Chapter 4.2, Quick Review Exercise 1 through 10. Section 4.2 in our book has to do with finding trigonometric functions of acute angles. And so these quick review exercises are just warm-up exercises to that end. In exercise 1 through 4, use the Pythagorean theorem to solve for x. Well, Pythagorean theorem is probably the most famous equation in mathematics, and that is the equation a squared plus b squared is equal to c squared. So if you know two sides, in this case we have this side on the left, which is the height of the triangle, is A, and the base of the triangle, which is B, we know that a squared, we'll say a squared is going to be 5 squared plus b squared, which is 5 squared, is equal to c squared. Well, this unknown side x we'll say is c, and so 5 squared plus 5 squared is 50, so we'll say 50 is equal to c squared. And now I'm going to bring this equation up to the top. I'll put c squared equals 50, and so we can solve for c by taking the square root of both sides of this equation. In doing that, we get c is equal to, we'll say plus or minus the square root of 50. And 50 can be rewritten as 2 times 25, so I'm going to put c is equal to plus or minus the square root of 2 times 25. Well, we'll rewrite this as c is equal to plus or minus, we're going to have the square root of 2 times the square root of 25. And what is the square root of 25? Well, the square root of 25 is 5. So we'll say c is equal to plus or minus 5 times the square root of 2. Now, one more thing, this plus or minus thing. Let's take a look at distance, analyze distance. Can we have a negative distance? No, we cannot. So this is an instance where, using the square root method to solve, we only have one solution, not plus or minus, because we cannot have negative distance. That eliminates our negative number solution. So we call our answer c equals 5 square root of 2. And if you wanted this decimalized, if you put this in your calculator, for instance, you would have got 5 times 1.407, something like that. But this is the exact radicalized answer. No calculator needed. Okay, next on our problem, which is 3, we have, again, use the Pythagorean theorem to solve for x. Well, in this case, we have a little bit different situation because we can say 10 is equal to a in the formula, and actually 10 is equal to c, which is our long side. We'll say 8 is equal to a, and x is equal to b. So if we have, again, a squared plus b squared equals c squared, that would give us a squared, which is 8 squared, plus, we don't know what b is, we'll say that's going to be x squared is equal to 10 squared. And so, rewriting this equation on top, we will have 8 squared is 64, so we'll say 64 plus x squared is equal to 100. And solving for x, we're going to subtract 64 from both sides of this equation. And so we have x squared is equal to 100 minus 64, which is 36. And so x squared equals 36. We can solve for x by taking the square root of both sides of this equation. So we have x is equal to square root of 36, which is 6. And again, normally in solving an equation, without regard to the context, we would say x would be equal to plus or minus 6. However, since we know that a distance cannot be negative, only positive, we know this is our answer. And this would be, for those of you who remember back to the geometry class, an example of a 3, 4, 5 right triangle, where we don't have 3, 4, 5, but we have multiples of 3, 4, 5. 6 is a multiple of 3. In other words, 3 times 2 is 6. 8 is a multiple of 4. 4 times 2 is 8. And 10 is a multiple of 5. 5 times 2 is 10. So that's an example of a 3, 4, 5 right triangle. In exercises 5 and 6, convert units. And to convert 8.4 feet to inches, we have to know the conversion factors. Well, we should know, it should just be a common known fact that 12 inches is equal to 1 foot. That's something in your science and mathematical literacy you should just know. And so if we start out with 8.4 feet, we work out the principle of dimensional analysis. And so we're going to write this 12 inches equals 1 foot as a ratio. That's going to be 12 inches per foot, or we can write this as the reciprocal of this ratio, 1 foot per 12 inches. And the ratio that we use depends on what we need to cancel. Okay, so we're going to multiply by this 8.4 feet by one of these ratios. Well, to convert to inches, we have to multiply by the ratio that is going to cancel out these feet. And how is that going to happen? Well, it's going to be only if we have our feet here in the denominator to cancel out this foot here next to this 8.4 in the numerator. So the ratio we multiply by is 12 inches per foot. And we can tell if we got this right if the units cancel out to leave inches by themselves. And if we cancel foot divided by feet, all we have is we have 8.4 times 12 inches. And for that, I guess we could conceivably do it without a calculator, but we'll just go to our calculator and put in 8.4 times 12. Here's 8.4 times 12, which is going to be 100.8 inches. So we go here and 100.8 inches. Now, working the odd number problems, I'm not going to work out problem 6, but what is the conversion factor between feet and miles? Well, again, it should be something as part of your mathematical and science literacy, but 1 mile is equal to 5,280 feet. That is the elevation of the Capitol building in Denver, Colorado, 1 mile high. Next odd number problem, exercise 7 through 10, solve the equation, state the correct unit. In this case, our equation is 0.388 equals A over 20.4 kilometers. So we can isolate this A. What is this 20.4 kilometers doing to this A? Well, it's dividing. So if we multiply this whole equation here by 20.4 kilometers, what happens is we have 0.388 times 20.4 kilometers is equal to A times 20.4 kilometers over 20.4 kilometers. What do you notice is going to happen on the right side of this equation? We have 20.4 kilometers over 20.4 kilometers cancel each other. So our answer is going to be A is equal to 0.388 times 20.4 kilometers. And I'll just put K in there. And so A is going to be equal to the calculator. Go to calculator 0.388 times 20.4. So we get 7.9152 kilometers. Kilometers. And that's our answer to problem 7. Okay, for our next on our problem 9, we have 2.4 inches over 31.6 inches equals A over 13.3. And so we're going to do similar to what we did in problem number 7, is multiply this entire equation by the denominator that's keeping this A from being by itself, which is 13.3. So we're going to have 2.4, we'll say inches over 31.6 inches times 13.3 equals A times 13.3 over 13.3. So this is, in essence, a cross multiplication of 13.3 to the other side. So A is going to be equal to 2.4 times 13.3 over 31.6. And what happens here to inches over inches above here in purple? Cancellation. So we'll go ahead and calculate our answer. Two 0.4 times 13.3 divided by 21.6, 31.6, and we get 1.01013. I think that's an irrational number. .01013, and so that will be our answer for problem number 9. And no units. There are no units. Why not? We canceled inches over inches, so no units. So that's our odd number problems worked out. Good luck with your even number problems as a demonstration of your learning as a preparation to go into chapter 4.2. Thanks for viewing.